Just 2 months after 9/11, New Yorkers were still terrified of the skies, but it happened again. On the 12th of November 2001, hundreds of families boarded a flight from JFK, most of them headed home to the Dominican Republic. But minutes later, that Airbus A300 tore apart over Queens, killing all 260 souls on board and 5 people on the ground. At first, many assumed it was another terrorist attack, but investigators uncovered something very different. This is the forgotten tragedy of Flight 587, a disaster caused not by bombs, but by error, flaws, and a deadly misunderstanding of how to fly a modern jet. The Airbus A300 had been flying for 13 years under American Airlines until November 2001. By that time, it had flown for 37,550 hours. That's like flying non-stop for over 4 years. Plus, the plane had also completed 14,934 flight cycles. In aviation, one flight cycle means simply one takeoff and one landing. This is how airlines count how many trips a plane has made. But even after this much service, the plane's maintenance records showed no problems. Government safety inspectors had also checked everything, and the plane passed all tests. The plane's weight was also correct for takeoff, neither too heavy nor too light. In the days before the accident, the people who put fuel in the plane and the mechanics who checked it saw nothing wrong. Even on the night of November 11th, the plane had flown from San Jose to Miami and then to New York. The pilots who flew that route said the flight was totally fit and fine. Finally, on the morning of November 12th, the ground crew started putting fuel in the plane around 7:10 in the morning. They watched one of the pilots walk around the outside of the plane to check it. It's a routine check. The maintenance logbook, which is like a diary of any problems with the plane, showed no issues. The entry from November 11th simply said no items, which simply means nothing was wrong. Besides, American Airlines records also showed no parts that needed to be fixed later, and no damage to the vertical stabilizer, which is the big upright part of the tail. It helps keep the plane flying straight, like the fin on a fish. What's even more incredible about this aircraft was that even after a violent turbulence incident in '94 that injured 47 people, a detailed tail inspection found no issues with this aircraft. And this clean history of the aircraft makes this case even more dramatic, shocking, and terrifying. Because we have just 2 questions. Then how did this happen? If a perfect aircraft wasn't safe from disaster, how safe is the plane waiting for you at the gate? The 2 pilots flying Flight 587 that day were no rookies. The captain, Edward States, was 42 years old and had been flying for American Airlines since 1985. He had his ATP certificate, which is kind of the highest license a commercial pilot can earn. By 2001, he had logged over 8,000 hours in the air. Of those hours, 3,448 were as the main pilot in charge of the plane, and 1,723 were specifically flying this A300 aircraft. The night before the flight, the captain had followed his normal routine. He was off work the day before, went to sleep around 10 at night, and woke up early on November 12th at about 4:16 in the morning to get ready for work. His family and work records showed he was healthy and well-rested. On the other hand, the first officer, Sten Moline, was 34 years old. He had been working for American Airlines since 1991. He also held an ATP certificate, though he needed glasses to see clearly while flying. He had flown for 4,403 hours total, with 1,835 of those hours as the second-in-command on A300 planes. Like the captain, he had been off duty for 3 days before this flight and had kept a good sleep schedule. Both men were up to date with their training and had passed all their required flight tests. Neither had ever been in trouble or had problems with their flying licenses. When investigators later talked to their colleagues, they heard only good things about both pilots. But there was one important detail that came to light when the investigators dug deeper. In 1997, this same first officer had been flying a different type of plane, a 727, when he encountered something called wake turbulence. Wake turbulence is the rough spinning air that a plane leaves behind it, like airwaves in the sky. It sounds pretty simple, but these air currents can shake and jerk a plane heavily that flies through them. So when this happened, a fellow pilot remembered that the first officer had responded very aggressively. He had pressed the rudder pedals, which moved the tail fin to turn the plane left or right, almost all the way to one side, and then quickly slammed to the other. But pressing the rudder too forcefully at high speeds can be dangerous. So the captain on that earlier flight in 1997 had been quite surprised. He later told the first officer that using such extreme rudder movements wasn't the right way to handle wake turbulence. But the first officer defended his actions, saying he was following what he learned in a special course, Advanced Aircraft Maneuvering Program training. And this detail would become very important to investigators and to us as well. It was a pleasant morning on the 12th of November in 2001. The crew of Flight 587 started their day early. The captain arrived at work around 6:14 in the morning, while the first officer showed up at 6:30. The flight attendants were already on the plane by 6:45, getting everything ready for passengers. Around 7:10, workers began pumping fuel into the airplane. It finished around 7:45, and then the plane just sat at the gate waiting. When every final check said the aircraft seemed perfectly normal, at 8:59, air traffic control told the crew they could push back from the gate. By 9:01, the control tower told them to drive the plane along the airport roads, called taxiways, toward runway 31 left. And as they rolled along these airport roads at 9:02, the captain asked the first officer to test the rudder pedals. So the first officer pushed both pedals all the way to make sure they moved freely. The runway at Kennedy Airport that morning was very busy. Just before Flight 587's turn to take off, a huge Japan Airlines Boeing 747 airplane had taken off from the same runway. This was important information because at 9:11 and 36 seconds, the control tower specifically warned Flight 587 about wake turbulence from that big 747. These airwaves left by the previous flight can be dangerous for smaller planes. So the tower told Flight 587 to wait before taking off. The pilots confirmed that request, and once enough time passed for those dangerous airwaves to settle down, Flight 587 got permission to move into position on the runway. Finally, the plane lined up on runway 31 left and started rolling forward for takeoff just after 9:13. At 9:14 and 23 seconds, the first officer called out V1. This means they just crossed a final checkpoint where pilots can't safely stop the plane anymore, and they have to take off no matter what. A second later, he said rotate at about 90 kilometers per hour. That meant it was time to pull the nose of the plane up into the air. Finally, the Airbus airplane lifted off the ground at 9:14 and 24 seconds, climbing straight ahead in the same direction as the runway. At 9:14 and 28 seconds, they reached a safe climbing speed with some extra margin for safety. And 2 seconds later, at 9:14 and 30, they raised the landing gear also. 11 seconds later, the wing flaps were folded up and the engines were set to climbing power. In the next few seconds, the aircraft climbed smoothly up through 2,000 to 5,000 feet above the ground. At 9:15 exactly, the air traffic controllers then gave them permission to climb even higher, to 13,000 feet. The weather was clear and Flight 587 climbed steadily through 5,000 feet above New York. So far, it was a perfectly normal flight, which just couldn't go wrong. But trouble was waiting just ahead. The massive Boeing 747 jumbo jet that had taken off minutes earlier left behind invisible but dangerous wake turbulence. Though the Flight 587 waited for some time before taking off, that wasn't enough. The first hit of the turbulence came almost immediately. The plane suddenly started shaking and tilting as the pilots fought to keep it steady. The rudders shifted a little while the plane tilted and turned. But the experienced crew quickly brought their plane back under control. But they only tackled the first hurdle. The second punch came at 9:15 and 44, when the captain calmly remarked about the little wake turbulence. By now they were climbing through 2,300 feet, picking up speed. Within 4 seconds, another wave of turbulent air slammed into Flight 587. This time it hit much harder. The control wheel jerked 64 degrees to the right, while the rudder pedals moved nearly 2 inches. That's a lot. The plane began tilting left, fighting against the pilot's commands. Being stressed, the first officer called for maximum engine power as their speed dropped to 240 knots. And this time, the captain of this flight also sensed his colleague's struggle and asked if he was okay. But was he okay? Or was the situation truly bad enough not to make him okay? The next few seconds will make it clear. At 9:15 and 56 seconds that morning, a sharp cracking sound echoed through the cockpit. 1 second later, the co-pilot called for more engine power as a heavy banging noise shook the plane. It felt like a giant hammer hitting the aircraft's body. Engineers later found that massive wind forces were tearing at the plane's structure. But the pilots couldn't get it until 12 seconds later, the unthinkable happened. The metal joints that hold the tail fin broke under incredible pressure. The result? The entire vertical tail fin, which looks like a shark's fin standing upright, ripped completely off the aircraft in midair. Both the pilots and passengers heard a thunderous bang as this 30-foot-tall piece of metal tore away. The plane was flying at 251 miles per hour, much faster than it was designed to handle such stress. When the tail fin broke off, naturally the rudder that steers the plane left and right became useless. At that point, the aircraft became like a car without a steering wheel. The captain felt the left wing suddenly also jerk upward as the tail departed. The smooth airflow over the plane's body turned chaotic, causing it to spin wildly. The crew fought desperately to control their aircraft, but it was impossible without the tail fin. And within 8 seconds of losing its tail, Flight 587 plunged toward the ground at Belle Harbor. The force of tearing off the tail ripped off both engines too, which fell several blocks away, hitting a gas station, a house, and a boat. Losing the engines cut power to the flight data recorder instantly, while the cockpit voice recorder, running on backup power, stopped as well. The plane was about to stall, and simply put, it already crossed the point of no return. The last words were the first officer saying, "What the hell are we into? We're stuck in it." And the captain replying, "Get out of it, get out of it." But seconds later, the plane violently crashed at Newport Avenue and Beach, 131st Street. It was clear that the flight would have no survivors left after this crash. The jet itself shattered into countless pieces. Nothing stayed whole. A mile away, investigators pulled the tail fin out of Jamaica Bay. The engines lay scattered blocks from the main wreckage. Everyone on board was gone: 2 pilots, 7 flight attendants, and 251 passengers. But on the ground also, 4 houses were completely destroyed, 3 badly damaged, and 5 more lives were lost. It was a terrible aviation failure beyond anyone's understanding. But the teams of investigators had to find out what went wrong. The National Transportation Safety Board, or NTSB, along with other agencies, began piecing together the puzzle. And they found 2 crucial devices in the wreckage: the flight data recorder and the cockpit voice recorder. These black boxes told a troubling story. In the last moments before the tail broke off, the first officer was doing the same questionable thing, shaking the rudder side to side and quickly pushing hard on the foot pedals. The data showed he pushed these pedals back and forth multiple times quickly. He did it because the plane hit wake turbulence and he was just trying to keep it steady. But this weird attempt caused the plane to slip sideways until the extreme stress broke the parts that hold the tail fin in place. The investigators also took a hard look at how this particular airplane, an Airbus A300, was designed to be controlled. Unlike many other jets, this plane's rudder system was built to give pilots the same steering power whether flying fast or slow. Most planes are designed so that at high speeds the controls become less sensitive to prevent exactly this kind of problem. But on this Airbus, even at speeds over 250 knots, pilots could still swing the tail dramatically with just moderate pressure on the pedals. Besides, the plane had safety systems designed to help smooth out flight, including something called a yaw damper that prevents unwanted side-to-side movement. But these systems weren't designed to stop a pilot from making rapid, full-force opposite movements of the rudder pedals. Why? Because no one thought any pilot would do such weird movements. Those movements were like asking a strong person to keep changing direction every fraction of a second while running at full speed. The investigation found nothing wrong with the tail itself. The metal and composite materials were sound, and all the bolts and connections were properly installed. But the forces created by the rapid to and fro rudder movements exceeded what the tail was designed to handle. Engineers call it an ultimate limit, the maximum stress a structure can take before breaking. The only reason the tail held together as long as it did was because of built-in safety margins. Airplane parts are always designed to be stronger than they theoretically need to be, just in case. But even these extra safety margins weren't enough for the extreme forces created that day. But what exactly made this situation particularly so dangerous? It was something called aircraft-pilot coupling. This happens when the pilot's actions cause the plane to move in a way that makes the pilot react even more dramatically, creating a vicious cycle. The first officer felt the plane rolling and tilting, moving side to side, so he pushed harder on the controls, which made the plane move more violently, which made him push even harder. After the crash, investigators also examined the training that American Airlines gave its pilots. Turns out the airline truly had a program called Advanced Maneuvering Program that taught pilots to use the rudder when encountering turbulence from other planes, especially during practice sessions at low speeds. The first officer was doing what he had been trained to do. He simply thought an engine had failed and was trying to control the plane using the rudder. Tragically, the captain recognized the danger and tried to stop the excessive rudder use, but it was too late. The final official report placed the primary blame on the first officer's unnecessary and excessive rudder pedal inputs. But investigators also noted that the airplane's rudder system design and the airline's training program contributed enough to the tragedy. The investigators were careful to point out that the pilots weren't accused of intentional wrongdoing. Under extreme stress and confusion, the first officer did what he believed was right based on his training. The airplane responded exactly as it was designed to, but in a way that no one had expected would be so destructive. In the end, this wasn't a case of mechanical failure or sabotage. The systems and parts all worked as they were built to work. Instead, it was a deadly chain of events. The plane hit turbulence from another aircraft. The co-pilot made excessive control inputs trying to recover. The tail couldn't handle the resulting forces. The structure failed and the plane crashed. So the crash revealed a dangerous blind spot in pilot training. Not only Moline, the first officer, but also many other pilots believed that a plane's computer systems would always protect them from pushing the aircraft too hard. They thought the rudder had built-in safety limits that would prevent damage, and this was dangerously wrong. The safety board made urgent recommendations to fix these problems. They told the Federal Aviation Administration, which oversees all flying in America, to create stricter rules about how sensitive a plane's steering should be. They wanted all passenger planes to handle smoothly and predictably when pilots moved the rudder. The investigators also demanded changes in how pilots were taught. They discovered that many pilots didn't understand a crucial fact. Even when flying at supposedly safe speeds, aggressive back-and-forth movements of the rudder could create forces strong enough to literally tear the tail off an airplane. It's like how rapidly jerking a heavy door back and forth can eventually break its hinges, even if each individual push seems gentle. Within days of these recommendations, aviation authorities in both America and France ordered immediate inspections of hundreds of similar aircraft. Mechanics had to carefully examine the metal joints where the tail connects to the airplane body, looking for tiny cracks or signs of stress that could lead to catastrophic failure. Airlines were given just 15 days to complete these emergency checks. Airlines also quickly updated their training programs and flight manuals. American Airlines, the company that operated the crashed plane, issued strict warnings to all their pilots. They made it crystal clear that aggressive rudder movements, rapidly pushing the pedals back and forth, were absolutely forbidden. Other airlines also followed suit, rewriting their rulebooks to emphasize that the rudder should be used like a delicate surgical instrument, not a sledgehammer. Aircraft manufacturers also jumped into action. Companies like Airbus and Boeing published new guidelines explaining exactly how their planes should be flown. They warned that sudden full movements of the rudder could break the airplane's structure. The most important change was in pilot education. Before this crash, many training programs focused mainly on engine failures and bad weather. Now they had to teach what happens when a pilot accidentally puts too much stress on the airplane itself. Today, every airline pilot learns that smooth, gentle control movements are not just preferred. They're essential for survival. But to learn this simple thing, a total of 265 people had to accept such a severe death. But here's the question. If even a perfectly maintained plane flown by experienced pilots could fall from the sky in seconds, what does that say about the risks we still don't fully understand? Because every brand new day, every brand new mistake. So how much trust should we place in training, design, and human judgment when lives depend on them? Let me know in the comments below, and don't forget to like, share, and subscribe if you want more untold stories of aviation disasters.